Okay, now let's move on to the next topic. So now from now on, it's going to be a lot of theory. So first we'll learn about angles and direction. So you might have thought that angles are only positive. Well, that's not true. So let's look at the thing. So angle measurement. Suppose P lies anywhere on the unit circle and here, and A is 1 comma 0. So 1 comma 0. Let theta be the angle measured from OA on the positive axis. So theta is positive for anti-clockwise rotations and negative for clockwise rotations. Okay, so this may seem complicated, but all you need to know is this. So if you make an angle with respect to the x-axis and you go anti-clockwise, then this is going to be plus. The angle is going to be positive. So this is the positive direction, this way. And then if you go the other way around, it's going to be the negative direction. So let me draw something. This is going to be plus 30 degrees, and this is going to be negative 30 degrees. And also, since this is a periodic cycle, so if this is the angle, then this is also equal to negative 330 degrees. This may seem very confusing, but you just need to believe it. The way we derive this is pretty simple. We just have to subtract 360 from it. We get negative 330. So if we add 360, it's going to be 330. So negative 30 is also 330 degrees. This only works because it's a circle and it keeps repeating, you know. So that's why this is true for angles. Okay. So if theta is this, then this angle will be negative 150 degrees. So now that we've learned about the direction and angles, let's move on to another topic. So this one. So for theta in radians, and k is an integer, positive integer. This is extremely important. It has to be a positive integer value. So this is going to be, so cos of theta plus 2k pi is cos theta. Okay, now you might be very confused right now, but just think about it. This is a circle, right? This would be 360 degrees, right? What comes after that? Just imagine you go around the circle once completely and a little more. Let's say this is 10 degrees. But you have gone around 360 plus 10 degrees, which is 370, but it is also 10 degrees. Now, is that clear? So, I hope it makes sense, you know. So, this will basically be a multiple of either 2 pi or 360 degrees. So, yeah, it also applies for sine 2. So, let's say 100, what would this also equal to? This will also equal to minus 360, which is 750 degrees. It's one and the same. And then if you keep subtracting 360 from it, it's going to be 390, which is greater than 360. So if you travel 360 degrees and more, 30 more degrees, then you'd complete that. So we can derive that 30 degrees is also equal to 1110 degrees. If you're not very sure, you're still in denial, just take out your calculator and type cos 1110 and subtract that by cos 30. You'll get 0. You can try it for like how many other numbers you want. You can use a different value and then try to derive this or anything. Just try it out. Use like angles like, I don't know, 5,675 and then subtract 360 from it. Keep doing that and then find the value of cos of that particular angle. And if you get the same, then this concept is right. Yeah, you can try that out so that you're like very sure. Okay. And now we're moving on to like sine and cosine. For that, we just need to identify certain things. So first of all, you need to know what a hypotenuse is. It's gonna be this line. We've learned this in like Pythagoras theorem in like 6th grade, 5th grade. So yeah. And if this is the angle, then the opposite side will be opposite of it. So this would be the opposite side and this would be the adjacent side. Whatever is not the opposite, it's going to be the adjacent side. Okay, now that we know these three terms, let's apply it to another triangle with a different angle. So the angle is placed here and not here. So this would be the opposite side. This would be the adjacent side. And this would be the hypotenuse. So if this is clear, let's move on to sine and cosine. Sine and cosine are just ratios. All you need to know is that they're ratios. So if you understand that, then it will be easy for you to learn the concept. Okay, so now let's look at this. So consider a point P, which is A comma B here, which lies on the unit circle in the first quadrant. So I hope you guys know what the quadrants are. This is the first quadrant, this is the second quadrant, this is the third, and this is the fourth quadrant. First, second, third, fourth, anti-clockwise, starting with the right topmost one. Okay, so it's shown here. And now if we want to find cos theta, sine theta, and tan theta, we're going to have to apply ratios. Or we're just going to divide certain things in order to find these. So first, we'll start with sine theta. So sine theta is opposite by hypotenuse. It's opposite by hypotenuse. It's going to be the same. This formula is going to be the same for any triangle that you take. So the opposite side would be B and the hypotenuse would be this. So it's going to be B by 1, which is B. So sine is opposite by hypotenuse. And cos theta would be adjacent by hypotenuse. So adjacent would be A by 1. The hypotenuse would be 1. The adjacent side would be A. So it's going to be A by 1, which is A. So sine is opposite by hypotenuse. Cos theta is adjacent by hypotenuse. Okay, I'll draw a figure here. Tell me what would be, let's say this is 5, 6. Okay, that's 3, 4, 5. What's sine theta? I'll give you 2 minutes, write down the answer. and then we'll check. So sine theta is opposite by hypotenuse. Opposite is 3 and hypotenuse is 5. So it's going to be 3 by 5. And what would be cos theta? Cos theta would be adjacent by hypotenuse. So it's going to be 4 by 5. Okay, now if that is clear, then let's move on to tan theta. Tan theta itself is a ratio of cos and sine. Yeah. So it's it's also sine theta by cos theta, which is tan theta. But if we want to write in terms of opposite and adjacent, we can write opposite. So tan theta would be opposite by adjacent, which is b by a, which is essentially sine by cosine, which is b by a also. So these are the ratios. It's very important to know them. So let's repeat that. Sine is opposite by hypotenuse. Cos theta is adjacent by hypotenuse. Tan theta is opposite by adjacent, which is also sine theta by cos theta. This is the thing. And now let's look at this. In general, for a point P anywhere on the unit circle. So unit circle is this, starting with the ordinal 0.0 with radius 1. So cos theta is the x-coordinate of P. That makes sense because cos theta is A, right? And sine theta is B. So obviously P would be cos theta comma sine theta for like all the points anywhere in the circumference.